Okay, here's going to be a pretty lengthy walkthrough of a few trig word problems that I'm going to help you do, and um, you're going to have a few to try at the end, and I'm going to supply the equations and the answers. All right, so first off, we got some keywords up here that's going to help us on these two triangles at the top of each of our pages. So our question is, a nursery plants a new tree and attaches a guy wire to help support the tree while its roots take hold. An 8-foot wire is attached to the tree, so that's pretty important. Let me go ahead and just take care of that. An 8-foot wire. Definitely need that. Is attached to the tree and a stake to the ground. From the stake in the ground and the angle of elevation, so we got an angle of elevation is 42 degrees. Find to the nearest tenth of a foot the height of the connection point to the tree. So find the height of the tree. Okay, so we have angle of elevations, and the angle of elevations are always on the ground, so we have our angle of elevation right here. And then we have some keywords. Tree is something that's very popular. That's always going to be our vertical line. So I can go ahead and say I got a tree, and I got an angle of elevation that has to go on the bottom, and that's 42. So angle of elevation is always on the bottom. Okay, so I also have an 8-foot wire. Okay, so if you take a look at this guy, string or cord is always the hypo. I hope it's safe to say that string, cord, a wire can qualify into that category as well. Okay, so I have a number now. This cord is 8 feet. Find the height of the tree, and I'm just going to use h for height. All right, so here's our equation, or sorry, our picture. So let's go ahead and identify some things. So I got, according to angle 42, this is the opposite. It's across from angle 42. And we should all know, hopefully by now, this is the hypo. Remember, it's always across from the right angle. So I am going to use opposite over hypo is sine. So I will say sine 42. Okay, the sine of that angle is opposite over 8. So I'm going to let you take a second by yourself to solve this real quick. Okay, so I went ahead and paused it and found the answer, and I hope you got it to agree that I got the height of the tree right around 5.9. 5.945. So that's about 5.95. Right around 5.9. All right, so the next one. Okay, so I got the same image up there. Ladder 5 meters long, leaning against a vertical wall, makes an angle of 65 degrees with the ground. How far is the foot of the ladder from the base of the wall? Okay, so let me take a look in here, highlight it. So I got a ladder. Okay, I got an angle of 65, and then it wants to know how far away from the foot of the ladder. Okay. So let's go in here. We've already talked about ladders before. Remember, our ladder is always the hypotenuse, so our ladder is the hypotenuse, and I'm going to make that 5. Angle of 65, so I got 2 angles to work with. I'm not going to work with this right, so leaning against a vertical wall makes a 65-degree angle with the ground. Well, always the ground is on the bottom. That is always going to be our angle of elevation. Okay, so now I need to put my variable on one of these sides here. So how far away is the foot from the ladder? Okay, distance from. That's how far away. Distance from is always measured along the ground, from foot to foot. So if you were standing here that was your foot and this was my foot, we would always be measured distance from. So distance from is always along the ground, so my X is on the bottom. So let's think here. According to angle 65, this is the adjacent, and this is the hypo. And let's go ahead and set this up to be cosine. So it's going to be cosine 65 equals adjacent over hypo. So I'm going to pause this a second and find the solution, and I hope you do too, and we can hopefully agree at the end. All right, so I got right around 2.11. So 2.11 feet away works for me. It's not very far away from the wall, and the ladder is not very big. So at least we know it's under the hypo. It's got to be under 5, so we're right there where we need to be. So on to the next one. A boy flying a kite lets out 200 feet of string on 28-degree angle of elevation with the ground. How high off the ground is the kite flying? Okay, so let's see some keywords I want you to pay attention to. I got a kite. I got 200 feet of string. I got 28 degrees angle with elevation with the ground. And then how high off the ground is the kite? So that looks like a height to me. How high off the ground? That's a height. Every time we need to find height, that is always this vertical line. So I know I'm going to find this height anytime. Now, that could be the string of the kite. So maybe the string or the kite's up here at the top here. And the height's going to be 90 degrees with the ground. So why is this kite string not this? Because kite string is always going to be with the string cord or wire. It's always going to be a hypo. So my 200 is actually going to be the hypo. Okay, so then I need to put this angle in here. 28-degree angle of elevation with the ground. Well, I can just throw that down there. So now that I have everything labeled the way it should be, and this is correct, I got an opposite to the 28 and a hypo of the triangle. And this, again, is going to be sine. Opposite and hypo is sine. So sine 28 equals h over 200. All right, so I'm going to pause for a second to do the math, and hopefully you do too, and we can come back together and agree. Okay, so I'm back. After doing this in my calculator real quick, I got around 93.89. So it didn't say to round to anything, so I'm just going to keep it at that. And hopefully you agree. Did the sine of 28, and then I multiply it by 200. All right, so let's move on to this last one. I'm going to walk you through, and I'm going to have you check to see if you can do a couple multiple choice ones. From the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. Okay. First time that I'm walking you through an angle of depression. That's the first time. We've been doing angle of elevation. If the tower is 45 feet height, okay, so tower is 45 feet in height, how far is the partner from the base? That looks like a distance from. Okay, remember, distance from is always along the bottom. So I already know this is my missing side down here. Okay, so let's see what to do with this angle of depression. And I have that over here on this side. Okay, an angle of depression is going to be on the outside of the triangle. So here's how I'm going to show this to you. And hopefully in class we talk a little bit more about it. So here's my angle of depression right here. Why is this the angle of depression? So anytime you are traveling, anytime you're like, that's the best way to describe this is in a plane. When a plane is at, sea level or altitude, it's going straight ahead for its passengers as they're flying, across country, whatever. And as they start to land, they actually start to go down at an angle. So if they are moving forward and they have to go down 10 degrees towards the landing, they're dropping this from eye level to 20 degrees. So this is going to be our angle of depression, as if we're going straight ahead and the plane will drop down 40 degrees. An angle of depression is going from straight across to start to descend down towards a landing. So what do we do with that is we imagine that we see this. Okay? We imagine that we have two parallel lines with the transversal being the hypotenuse of this triangle. So all we do with this is we act as if we have alternate interior angles. So we do this little $sign effect, and that 40 comes inside the triangle on the bottom. So this is the actual angle we will use. We will not use anything outside of the triangle. We're picking an angle inside. So that is how we put the angle of depression inside our triangle. So I got a 40. I know it's a distance from, because the distance from is always along the bottom. So now what I got to do with this green highlighted piece here, tower is 45 feet in height. Height is always an up and down vertical line. Okay, so I now have all the pieces I need in my triangle, so I can write my equation. And I'm going to say, according to angle 40, this is opposite, and this is adjacent, and I am picking tan because it's opposite and adjacent. So tan 40, and looks like this is our first word problem where the variable will be on the bottom of our fraction. So I'm going to push pause and do the math. I hope you push pause this time and try it yourself. All right, so I'm back. I did my math on the calculator and paper right beside me, and I got x to be right around 53.6. And hopefully you're right in the ballpark and agree with me. So the next problems, I think there's 4 after this. They're multiple choice. What I'm going to do is I'm going to let you read the question, and then I'm going to show you the picture. I'm going to let you try to draw the picture first, and then I'm going to let you try to show the work, and then we'll see if it's multiple choice. Let's see if you get where you need to be. Okay, so I am going to show you your first question. And here it is without the picture. I want you to go ahead and pause it, read the question, and try to draw the picture. And in a couple seconds here, make sure you pause it in a couple seconds here. I'm going to show you the picture. And then I'm going to let you try to work it out. Okay, so here is the picture I've drawn. So there is the picture the actual computer drew it. But here's what it came with. So from this picture, hopefully yours matches mine. Remember, the height's always dx that goes straight, the vertical line, distance from always goes along the bottom. Your angle of elevation is always on the bottom angle. And this is the equation that will get me where I need to be. So go ahead and see if you worked it out. I'm going to give you the answer in a second. I hope you pause it. Okay, I'm back. I did my math. I used that equation. My math came out to be 32.9, but it did say to the nearest foot. So I'm picking, if this was the second option, I guess that would be B. All right, so on to the next one. Here's your question. Give it a draw, push pause. I'm going to show you the picture here in a second. Okay, so I hope you paused and gave it a shot. Here is the picture that goes with that problem. Okay, so I hope yours matches. How far from the foot of the sign? Remember, this is not the height now. This is how far from, distance from. So our variable is going to go there. So based on that information, this is the equation I came up with, and I hope yours matches. So I'm going to give you a second to try it. I'm going to do it myself and pause, and hopefully we come back in a second and we get the same answer. Okay, so I paused and went and did the work. Well, actually, I was doing this. There should have been a cos 51 here. Hopefully, I'm sure all of you caught that. But when I did mine, I got about 50.03-ish. And this says the nearest foot. So I'm going right there. And I hope you agree. All right, so make sure you know you can pause on every one. I'm on to the third one. I'm going to give you a few seconds before I show the picture. Pause it, draw it, see if it matches. Okay, so here is the picture. All right, so the angle of depression is on the outside. So remember what we talked about. This is going to come in here at the bottom now, just like alternate interior angles. So there's the angle we're working with, not the angle on the outside. What I'm looking for is the height of the balloon, and I'm always going to use h for height, and the height of the balloon is always the vertical line. The string is wire, cord, whatever, is always the hypotenuse. So here's the equation that I created. Sine 62 equals x over 90. Give it a shot. I'll pause mine, you pause yours. Let's see if we agree. All right, I'm back. I paused, did my work. I ended up getting right around 79.46. But that would round up to 81. So I'm going with 79 here, not 81. I don't think it would go all the way up to 81. So I hope you agree. All right, so let's take a look at the next one. Pause and then try to draw the picture. I'm going to show you the picture here in 3, 2, 1, and that's what I got with our plane. So what are we looking for? It says, what is the distance from? Hopefully, we're in agreement there. And that is what side we're missing. And I am using this equation. I am using tan in the first time of these four that the x is actually on the bottom. Good luck. I'm going to try it myself and let's see if we agree. All right, I'm back. I did the math, and hopefully you agree with me. The closest one to it is this option 3, 28270. So I hope that helps you get started and gives you good help and examples for trig word problem.